Kia ora Year 9, hope you're having a nice weekend. Just wanted to do a quick video going through the extended abstract questions that we gave you to practice up your skills for the JAF on linear equations and graphs. So the first question here is a tricky equation where we've got n on both sides and we've got negative numbers and fractions. We've actually done lots of hard equations like this, so if you want to watch a video with more of them, there's a video that goes with the worksheet on Google Classroom, so go have a look at that one. I'm going to do this one reasonably quickly. I'm going to spend a bit more time on the second question, which is a really cool example of a graph that has a real life context. So let's get this equation one out of the way first. We're starting with this. So I'm going to solve it first, and then I'm going to talk afterwards about why I did it that way using a bubble diagram. The first thing I'm going to do here is to add 4n to both sides. You don't have to do this working, but with harder ones I think it does help you when you're checking what you've done. So adding 4n to both sides means that this won't be here anymore, because take away 4n plus 4n gives me 0. So we have negative, in brackets, 1 minus n over 3 is equal to negative 1 plus 4n. Next I'm going to multiply both sides through by 3, giving me this. Now it's probably time to expand out the brackets and then clean up. So we get negative 1 plus n is equal to negative 3 plus 12n. I'm going to collect up the n's on one side and the numbers on the other side. So it doesn't matter which way you go with this, but I think I'll add 3 to both sides. So negative 1 plus 3 gives me 2. So I have 2 plus n here, and I just have 12n here. Next I'm going to subtract n from both sides, giving me 2 is equal to 11n. Lastly I'm going to divide both sides by 11. So we get n is equal to 2/11. Now you can check that that solution is correct by putting it back into the equation. You don't have to do this, but let's see what we get if we do. On the left hand side we have this. So working that through gives me negative 9/11 divided by 3 minus 8/11. So this is the same as negative 9 divided by 33 minus 8/11. Simplifying this, looking at that common factor of 3, gives me negative 3/11 minus 8/11, which is negative 11/11, which is negative 1. And when we look right back to that original equation, that's what we wanted to end up with. Okay, so the two sides are equal. We've found our solution. Alright, let's have now a closer look at this next question. This is one where we have to first write an equation from the context, then draw the graph, and use the graph in the equation to figure out some information that we're being asked for. So Ailoni and Yosefa both work at Terrific Toys. Ailoni is paid $20 plus $12 per hour, whereas Yosefa is paid $10 plus $15 per hour. And you can see the graph here has got the variables on it. It's got T for time and it's got P for pay in dollars. So that means the equation that I'm going to write here is going to have, oh, don't know what happened there. Lost everything on my laptop. Sorry about that glitch. Right, so we're looking to write an equation for both of those things. And it's going to be P is equal to something, something, something for Ailoni. And then there'll be another equation, P for pay is equal to something for Yosefa. So if we think about how we can work this out, the $12 per hour is going to be the gradient in my equation, but Ailoni gets paid $20 to start with. So many of you watching this will be able to see straight away how to write that equation. I'm going to go through it after I do this using a table as well. So when Ailoni works no hours, just for being employed by them, he gets paid $20. So that's going to be my y-intercept. So it's P equals 20 plus 12t. Or in our usual format, P is equal to 12t plus 20. But remember, in class the other day we did lots of work on rearranging this form into this form. And this is now really easy to graph. So this is the pay that Eloni gets, and for Josefa it's going to be $15 per hour, so 15 times T plus 10. We need to now draw those two equations. So one way we can do this is to use our usual method, where we start with our y-intercept and then we use the gradient. So for Eloni, we're going to start at 20, and then we're going to go up each time by 12. But that's going to be quite hard to do accurately using my graph, because I can't easily see how to go up 12 up here. So I basically am better off to use a table and then find some nice round numbers that are going to work. The same thing for Josefa. I can put on my y-intercept at 10, so his line is going to start here, but a table is really going to help me. The other thing that's really good about doing a table is that if you find it tricky to go straight to the equation from the words, the table will help you out. So let's do a table for Eloni's pay. So the number of hours worked. Well, when he works no hours, we earn $20. 1 hour, 32. 2 hours, 44. 3 hours, 56, and so on. 4 hours, 48. Nope, not 48. Whoops. 4 hours, 68. And then for 5 hours, he earns $80. So I like that because that's going to be really easy for me to draw and then get an accurate line. So we can now put that point on. At 5 hours here, we've got this nice point here. We can take our ruler and join the dots up like that. So there we go. Okay, now we're going to do the same thing for Josefa's pay. We've got T here and we've got P here for pay. 0, 1, 2, and 3, and 4. So no hours, he earns $10. 1 hour, 25. 2 hours, 40, and so on. This point is going to be really easy for us to draw accurately. So let's do that one now. So 2 hours and $40. We'll just change his line colour. So 2 hours and $40 is here. So you can see that because his hourly wage rate is higher, the gradient is higher. And we're starting to be able to see where those two lines intersect, although it would be easier to see that if I did that in a better colour. Let's try it now in purple. There, that's better. Okay. Right, what do we have to do next? We've done the first part. So what pay would they each receive for working these hours for their pay to be the same? Let's see the question wording. Right, estimate the number of hours that they would have to work for their pay to be the same. So we're told to estimate that from the graph. We can also work it out exactly using the equations. But if we're just looking at the graph, let's see where they're earning the same amount of money. It looks like it's about here. So working that back down, let's see how many hours that is. We'll see how accurate we get it. Let's see. So let's draw down a dotted line here. So it looks like at about $60 they're doing the same number of hours for the same amount of money. So this is 2, 3, so it's just over 3 hours. So it looks to me like about 3 1/3 hours. That would be my guess. Right, here's 3 hours here, here's 3.5 hours here, maybe 3 1/4. Okay, so that's said to estimate it. And then what pay would they each receive for working these number of hours? Well, they would receive just under $60. So there's 40, 50, 55. I would say, let's see, what am I going to go with? I think I'm going to go with 3.5 hours. and $60. But we should be able to do better than that, and we're going to do that using the algebra. So where will this pay be equal to this pay? Well, we've got 10 plus 15t, so that's for Josefa, is equal to 20 plus 12t for Eloni. First we're going to find the number of hours, then we'll work out the pay. So subtracting 10 from each side gives me this. Now I'm going to subtract 12t from both sides. I get 3t is equal to 10. T is equal to 10 divided by 3, which is 3 1/3 hours. So that's 3 hours and 20 minutes. I'm assuming that they get paid by the minute, which is possibly not a great assumption, but it fits with having drawn the line all joined up. So what pay do they get when they work that number of hours? Well, I can now take this number and I can put it back into Josefa's pay equation or Eloni's. It doesn't matter because it's going to be the same. So P will be 10 plus 15 times 10 divided by 3. Remember, you're welcome to use your calculators. So we've got 10 plus 50, which is $60. So how did I do on my estimation? Well, I said way back up here, I said 3.5 hours, and the actual amount was 3 hours and 1/3, but I got the amount right. Okay, so that's what they'd receive for both working those hours. The next thing we're asked to do is to say that if Eloni worked 14 hours, how long would Josefa have to work to earn the same amount? So the first thing I'm going to do is work out Eloni's pay using his equation, this one here. I'm going to get that amount and then use it with Josefa's equation. Let's just check the question wording. Right, so Eloni's equation is 12t plus 20. So when t is equal to 14, he earns 12 times 14 plus 20, so that's $188. So how long does Josefa take to earn that much money? Well, we now take 188 and we have to solve for the value of t. So that gives us 178 is equal to 15t. T is equal to 178 divided by 15. Let's get some more space. So we have to give that answer sensibly. That doesn't make much sense yet. 178 divided by 15 works out to be 11 and 13 over 15, if we're turning that into a mixed number. And we want it in hours and minutes. So that's 11 hours and 52 over 60 hours. So the answer here is 11 hours, 52 minutes. So it's a very precise answer. So that's how long Eloni has to work for. Sorry, that's how long Josefa has to work for their pay. Wrong question. Okay, Eloni works 14 hours, so he earns $188. Josefa doesn't have to work as long to earn $188. He has to work 11 hours and 52 minutes. So there you go, quite a lot in that question. How to write equations from scratch, how to draw them on a set of axes where the scales are not quite what we're used to, and then how to answer problems in context. Let me know if you've got any questions. There's some really good Education Perfect on this, as well as some questions in the relational worksheets that we've posted. Thanks for watching.